Okay, we'll start now. In the last lecture, we had started with the definition of agri informatics. What you mean by computer? What are the history of computers? Okay, we'll just look at it again. This is the general anatomy of computer: output devices, input devices, the processor that is called as CPU, and mass storage devices. Okay, so we had looked at the history of computers. Who invented the computer? That is Charles Babbage, an English mathematician, a mechanical engineer, and a mathematician. Okay, how the computers evolved from the Charles engine, that is difference engine, to the recent computers, fourth generation computers. Mark One computer, ENIAC, UNIVAC, and the modern generation computer generations. That is first generation, second generation, third generation, fourth generation, and fifth generation, which is in development. Okay, so the difference is the use of the components for processing, that is vacuum tubes, transistors, IC, microprocessor, and for that in the fifth generation the artificial intelligence is been inbuilt like the robots. Okay, these were the five generations we had seen in the previous lecture also. We had seen the definition and the function of the computer, that is it receives data and instructions from input device, it processes the data with the use of CPU, and it provides the output in the desired form. That is the three operations that are performed by the computer in sequence. Next, advantages, limitations of computers, and this anatomy which I had given you for the assignment. Okay, this is the in detail part of computer, in detail parts of computers. Okay, and we had seen the input devices, CPU, output devices. All these devices we had seen. Okay, and memory unit, arithmetic and logical unit, and control unit. All these we had seen in the previous lecture. After that, hardware, software, system software, types of softwares. That are two: system software and application software. We had seen system software. Also, we had seen that included operating systems, all the library programs, all the translators. Okay, and the application software which is used by the user who uses the computer, which is used for the humans. Okay, these are called as application software. These are divided into general purpose softwares. All these are general purpose softwares. Okay, and special purpose softwares, that is payroll, billing, railway reservation, etc. And the firmware which is installed in the hardware so that the hardware can run, that is called as firmware. Okay, this was the lecture number 1. After that we will see what is meant by data representation and binary and hexadecimal systems. We had I just noted you down in the previous lecture, but we will see what are these data representation, what are the types of number system, and all these in detail. Okay, so data, it can be in any form. It can be a text, it can be a musical note, it can be a number, it can be a video, it can be an audio. Anything is called as a data. So it is in different form we can see the data. Okay, but for computer the data should be represented, or data is inputted in the digital form or a binary form like 0 1 1 0 0 1 1 0, like this the data should be inputted. Okay, it cannot be inputted as a video, it cannot be inputted as a audio, it cannot be inputted as a text. It should be inputted in a digital form, that is the digital data. Without the digital form, the CPU or any input device or CPU cannot accept the data. Okay, so in electronic device, the digital data should be inputted. So this process is called as digitization. It is the process of converting information such as text, numbers, photo, music into digital data that can be manipulated by the electronic device. So this data can be manipulated by the CPU or mouse or keyboard. Okay, this data, digital data, can be manipulated. That is called as digitization. Next, the number system. We have also seen what is meant by number system. There are two types of number system. First is non-positional number system and second is the positional number system. Okay, so we have seen what is meant by non-positional number system. Like we use in statistic also 141, 242, 343, 444 and tally marks. Like this tally marks, they represent a non-positional number system. So we are also seeing limitations. What are the limitations? It cannot be used to perform arithmetic operations. You cannot perform arithmetic operations with these numbers. With these numbers, you cannot perform the arithmetic numbers. You require such type of numbers. Okay, and it cannot be used for higher values of numbers. It cannot be used for lakhs, crores. Like this, it will become a very long number. It will become a very long number. Okay, you have to look at this number. This is a 5 number. Okay, so for 5, this is a very large number. So imagine for a millions or crores, it will be a very big number. Okay, so it cannot be used for a very high value of numbers. Next, we'll go with positional number systems. It uses a few symbols. These are called as digits. It uses a digit. So these symbols represent values depending on the position they occupy in the number. These symbols will represent different values depending on the position in the number. Okay, depending on the position, it will occupy the values. Say if I have a number called 15, 15, 1, 5. Okay, so the number 1 is in tens place and 5 is in units. Okay, so the value of 5 is 5, but the value of 1 is 10, not 1. So 10 plus 5, it will become 50. So depending on the position, it will occupy the value. That is called as positional number system. The types of positional number systems, these are the decimal number system, binary number system, octal number system and hexadecimal number system. In your syllabus, there are decimal number system, binary number system, and hexadecimal number system. Okay, these three number systems are there. So first, we will see what is decimal number system. So decimal number system we use in our day-to-day life for writing the numbers. So it includes 10 numbers or 10 symbols, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9 is represent the decimal number system. So there are 10 digits. These 0 to 9 are 10 digits. Hence its base. Base means this is the base. This you write as base. While writing the number, you normally write only 2586. But the actual number is written as 2586 to the base 10. To the base 10 in a computer system. Okay. So its base is 10. Its base is 10 and the maximum value of single digit is 9. Out of these 10 digits, the maximum value is 9, one less than this. And each position of a digit represents a specific power to the base 10. Okay, so this 10 to the power 2, 10 to the power 3. So this 3 is the position. This 3 is the position of this 2. Okay, this 2 is the position of this. This 1 is the position of 8. Okay, and this 0 is the position of 6. Okay. So depending on the position, the powers are denoted. The powers are classified as 10 to the power 1, 10 to the power 2, 10 to the power 3, like one. Okay. So like this, the positional number system or the decimal number system works. Okay, this is the number system we use in our day-to-day life. Next is the binary number system. It is also a positional number system. It has only two numbers, two digits. That is bi. Bi means two. So it has only two symbols or digits. That is 0 and 1. That is 0 and 1. Hence its base is hence its base is 2. The maximum value of single digit is again here 1. In decimal it was 9. In binary it is 1. 1 less than the base. 1 less than the base. Here also each position of a digit represents a specific power of the base 2. Because the base is 2, it represents the specific power to the base 2, like this: 2 to the power 4, 2 to the power 3, 2, 1, 2 to the power 0. Like this it will represent the values, okay, depending on the position. Okay, and this type of number system, this binary number system is used in computers. Without this binary system, the computer cannot accept the data. Third is the hexadecimal number system. This is also used rarely. This is used very rarely, but it is there in our syllabus. Okay, it is a positional number system. Again, it has total 16 symbols or digits. Out of this, 10 are included, which are included in decimal system, 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of this decimal number system, 10 digits are included, and hexa stands for 6. Hexa stands for 6. So these 6 numbers or digits are alphabets: A, B, C, D, E, and F. Okay. So A value is next to 9, that is 10. B value is 11, C value is 12, D value is 13, E value is 14, and F value is 15. F value is 15. So the highest value of a single digit is 15. The maximum value of a single digit is 15, that is one less than base. Base is 60. So one less than base. Highest value of single digit is 50. Okay. The values of A, B, C, D, E, F are 10, 11 to 15 respectively. Same, each position of a digit represents specific power to the base 16. So 16 raised to 2, 16 raised to 1, 16 raised to 0. Depending on the number system, the base will change. The base will change. Okay, that is the example of hexadecimal system, number system. So the base is here is 16, and this type of number is hexadecimal number system. Okay, so these were the three number systems which we had seen. Okay, now we'll solve some numerical on the number system. Okay, so first take a note on converting a number, converting a number, converting a number of another base, converting a number of another base. It's not a decimal number, it is of another base, say binary or hexadecimal. Converting a number of another base to a decimal number. Converting a number of another base to a decimal number. Say you have to convert a binary number into decimal number or hexadecimal number into decimal number. So while converting these numbers, you have to follow these steps. If you have to convert binary to decimal or hexadecimal to decimal, so you have to follow these steps. So what are these steps? First, determine the column or positional value of each digit. You have to determine the column or positional value of each digit. You have to write the positional value of each digit separately. That we will see in numerical. Okay. After this, multiply the column or positional values. Multiply the column or positional values by the digits in the corresponding columns. And third, calculate the sum of these products. Calculate the sum of these products. So write these steps, first three steps, only three steps are there. Converting a number of another base to a decimal number. Converting a number of another base into a decimal number. Converting a number of another base into a decimal number. Write these three steps. Only three steps are there. Determine the column or positional value of each digit. Determine the column or positional value of each digit. Determine the column or positional value of each digit. Next, multiply the obtained column values by the digits. Multiply the obtained column values by the digits in corresponding column. Multiply the obtained column values by the digits in the corresponding columns. And third step, you have to add the product. You have to add these products. You have to add the products. Calculate the sum of these products. So these are three simple steps. You will see now the numerical. How to convert a number of another base to a decimal number. So it may be a binary number or it may be a hexadecimal number. It should be converted into a decimal number. For that only these three steps are there. If the case is opposite, you have to follow a different method. If you have to convert a decimal number into a binary number or a decimal number into hexadecimal number, you have to follow different steps, different procedure. Okay, so this procedure is for conversion of binary number or hexadecimal number to a decimal number. Okay, so we'll take down this numerical, convert, just take down this numerical, convert the number 10101111. Convert the number 10101111 to the base 2. To the base 2. Convert the number 10101111 to the base 2 into decimal form. Into decimal form. Convert the number 10101111 into decimal form. Clear? Okay. So just you have to make a table. In the first row, position. In the first row, position, and in the second row, bit value. BIT. Bit value. In the second row, you have to write bit value. Bit value means this is one bit, this is second bit, this is third bit, this is fourth bit, fifth, sixth, seventh, eighth. Okay, likewise these bits are there. Clear? Position and bit value. In first row there is position, in the second row there is a bit value, BIT value. After this, in bit value you have to write the number 10101111. Whatever number is given here, you have to write just separately 10101111. 10101111. 10101111. You have to write separately. Okay, from LHS to RHS. Bit value should be written from LHS to RHS. Just you have to give, you have given the numerical 10101111. So I have written this separate 10101111. Now this right hand side bit, this one bit, this RHS bit, the bit which is to the extreme right, that is 1. This is the least significant bit, LSB. This is the least significant bit. Least significant bit is a bit which has less value, which has very least value. Okay, it doesn't have very high value, it has least significance or least value or least importance. That is called as least significance least significant bit, bit, LSB. So this extreme right, the digit to the extreme right is called as least significant bit. Similarly, digit to the extreme left, this is also one, it is the most significant bit, MSB. It is called as most significant bit. Got it? So this LSB, on the top of LSB, you have to write the position as 0. You have to write the position as 0. You have to start the position from 0. You have to start giving the positioning from 0, not 1. Okay. On the top of this least significant bit, you have to give the position as 0 and start increasing towards left and start increasing towards left. 0, 1, 2, 3, 4, 5, 6 and 7. When to stop? 7, because the last value is here. Last position is 7. Okay. Prepare this table, bit position and bit value. Okay. So what is the highest position? 7. What is the highest position number? 7. Okay. And the base here, the base is 2. The base is 2. Got it? So you have to write the position to the power of base. Okay. Base to the power of position. Okay. I said reversely, base to the power of position. Okay. So on the LHS, you have to write again the same number, 10 10 11 11 10 10 11 11 to the base 2, to the base 2. Just as it is, you have to write the same number, is equal to, fill in the blanks, into 2 raised to 7, because the highest value is 7, highest position is 7, into 2 raised to 7 plus, again fill in the blanks, into 2 raised to 6 plus, again fill in the blanks, into 2 raised to 5 plus, again fill in the blanks, 2 raised to 4. Likewise, go to up to, into 2 raised to 0, 2 raised to 0. Okay, got it? Fill in the blanks, into 2 raised to 7 plus 2 raised to 6 plus 2 raised to 5. Likewise, you have to go to up to 2 raised to 0. Any problem? आता problem असेल तर सांगा. Any problem?
नाही sir.
Okay. So you have to fill now this fill in the blanks. Okay, how to fill this fill in the blanks? Look at this power. Okay, this power is your position. For this 7th position, what is the bit value? You have to take a note of it. It is 1. For this 7th position, it is 1. So you have to write 1 in the fill in the blanks. You have to write 1 in the fill in the blanks. Similarly, for 6th position, the bit value is 0. The bit value is 0. So you have to write 0 in this. Similarly, for 5th position, you have to write 1. For 4th position, you have to write 0 again. For 3rd position, the bit value is 1. For 2nd position also, the bit value is 1. For 1st position, the bit value is 1. And 0th position, the bit value is again 1. So just fill in the blanks and the equation will be like this. 1 into 2 raised to 7 plus 0 into 2 raised to 6 plus 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. 1 into 2 raised to 0. Gopal Krishna. What is 2 raised to 0? Gopal Krishna. Gopal Krishna. Audible hai? Gopal Krishna. What is 2 raised to 0?
I don't know sir.
Huh?
I don't know sir.
Don't know. Okay. Mute करो. पाटील सॉरी प्रतीक तापकीर आहे का?
Yes sir.
What is 2 raised to 0?
0.
2 raised to 0, 0. Okay. Next, mm, for Priyanka, 2 raised to 0,
1, sir.
1. Okay. So 2 raised to 0 is 1. 2 raised to 0 is 1, not 0. Anything raised to 0, it will become 1. 1 raised to 0 will also become 1. 2 raised to 0 will also become 1. 3 raised to 0 will also become 1 only, not 0. Okay. So this is 1. So you have to take just product. 2 raised to 7 is 128 into 1, again 120. This is 0. Okay, because it is multiplied by 0. Again 2 raised to 5 into 1. 2 raised to 5 is 32 into 1, 32, plus this product is 0, plus this product is 8. 2 raised to 3 is 8, plus 2 raised to 2 is 4, plus 2 raised to 1 is 2, and 2 raised to 0 is 1. Okay, and you have to add these numbers. You have to add these numbers. It will come as 175. How many it will come? 175. And you have to write to the base 10 because you have converted into decimal form. You have to convert it into decimal form. So this value in binary format, it is 175 in decimal form, in decimal number system. So that is how you convert a binary number into decimal number system, or a hexadecimal number into decimal number system. If there is a hexadecimal number, its base is 16 here. Its base is 16. So instead of 2, you have to write 16. Okay, it will come as 16 raised to 7, 16 raised to 6. Likewise, the multiplication will go on. Okay, so only the base will change. Only the base will change. The position will remain same. Got it? So this is the procedure for converting of binary number or hexadecimal number into a decimal number. Now, हे समजलं का? Understood? Understood? ही प्रोसिजर समजली का? Understood this procedure?
Yes, sir.
Now the reverse procedure. Converting a decimal number. Converting a decimal number to a number of another base. That means converting a decimal number by a number or to a hexadecimal number. Converting a
Yes,
decimal
sir.
number. Huh? Converting a converting a decimal number to a binary number or a hexadecimal number. This is a reverse process. Okay, so this procedure is different than the we have seen in 2 minutes ago, 5 minutes ago. Okay, so this procedure is called as division remainder method. Division remainder method. We have done division in 5th standard. I think 5th standard. There was a division. 12 12 is divided by 5. Okay, how much the quotient will come if you divide 12 by 5? If you divide 12 by 5, how much the quotient will come? पासळे पासळे भाऊसाहेब पासळे आहे का? पसाळे का पासळे, काय नाव तुझं? भाऊसाहेब पसाळे. मी माईक ऑन कर ना जरा, अजून विचारायचं मला तुला. जर माईक ऑन कर. हा.
2, sir.
If you divide 12 by 5, how much the quotient will come? 2.
2,
बरोबर?
sir.
हा. And
Yes.
remainder
Two, sir.
also it will come as 2. So
2.
you divide 12 by 5, the quotient will come as 2 and the remainder will
And
come as
remainder
2.
2.
Okay, good sir. Okay. So this is a simple division remainder method. So in step 1, you have to divide the decimal number because you are given a decimal number. You are given a decimal number and it is to be converted to number of another base. So you have to divide the decimal number by the value of new base. So you have to divide the decimal number by the base which you have to convert. If you have to convert to binary number, the base should be 2. So you have to divide the decimal number by 2. If you have to convert decimal number to hexadecimal number, so you have to divide the decimal number by 16, not 2. So likewise, the conversion will take place. Second step, record the remainder. Record the remainder from step 1. You have to just find the remainder. The quotient is not important here. Only the remainder is important. Only the remainder is important. So you have to record the remainder from step 1 as the least significant digit, which is the rightmost digit. Okay, so this digit will become as least significant digit of the new base number. Okay, second, in step 3 again you have to divide the quotient. The quotient will come down. Okay, and it will divide by new base. It is divided by again the same base, like this. If it is 2, again here it is 2. Okay, and again you have to record the remainder from step 3, and it will come to the left hand side of this number. Okay, we will see. After this, you have to repeat the steps 3 and 4 until the quotient will become 0 or 1 or 1, anything. It will become 0 or 1. Okay, so likewise, this is a conversion of decimal number to a number of another base. Conversion of decimal number to a number of another base. Just write the steps. Just write the steps, or take a screenshot, because just take a screenshot of this. I will ask you while solving the numerical. Okay, next example. This is the numerical. Write the question, convert the number. Write the question, convert the number, convert the number 156. Convert the number 156, 156 to the base 10. 156 to the base 10, like this. You have to write like this. 156 to the base 10 into decimal form. Sorry, into binary form. Into binary form. Convert the number 156 into its binary form. Okay. Okay. So the this is question. This is your question. 156 to the base 10. So this 156 you have to write which the number which is to be divided. Okay, you have to write in this place 156. Okay, and it should be converted into a binary form. It should be converted into a binary form whose base is 2. The base of binary number is 2. So you have to divide this number 156 by 2. By how much it will come? The quotient will come as 78. The quotient will come as 78. Okay, the quotient will come as 78, and the remainder will come as 0, because there is no remainder. इसके नीचे कुछ रहता नहीं. So the quotient will come as 78 and remainder will come as 7. During 5th standard, you were to write the quotient on the top. Okay, on the top of this, or here also. Okay, but in this example or in this conversion, you have to write the quotient here and remainder to the right of this, and remainder to the right of this. Okay, so this is the one step. 156 is divided by the base of which it is to be converted, that is 2. Okay, and the quotient is calculated and remainder is noted or recorded, that is called that is 0. That has come as 0. Next step. Again you have to divide this 78. Again you have to divide this 78 by same number 2. By same number 2. Got it? And you have to write the quotient here. You have to write the quotient as here. Okay. Same process. 156 divided by 2, it has come as 78. Okay, and you have to write the remainder as 0. You have wrote the remainder as 0. Again 78 divided by 2, it will come as 39, and again the remainder is here 0. Remainder is 0. Next step, again 39 divided by 2, it will come as 19, and one number is remaining. Okay, so this remainder is noted as here. This remainder is noted as here. Got it? Same, 19 divided by 2, it will come as 9. Remainder is 1. This remainder is 1. Okay. Similarly, 9 divided by 2 is 4, and the remainder is again 1. Again 1. 4 divided by 2 is 2. 4 divided by 2 is 2, and remainder is 0. Remainder is 0. Similarly, 2 divided by 2 is 1, and remainder is 0. Okay, and this one you have to write here. If it was 0, you have to write 0 here. If it is 1, you have to write 1 here. Okay, so this is your new number, which is the decimal form, binary form of that decimal number 156. This is the binary form of this decimal number 156. So how to write this number? You have to start from here. Go from bottom to top. 100 111 00 to the base 2. To the base. So this 156 to the base 10 is equal to 100 111 00 to the base 2. So this is how you convert the decimal number into binary form. Same, binary to decimal, you have to multiply. Decimal to binary, you have to divide. You have to divide. Okay, the process is a little different, but you have to understand the difference. If you are converting binary to decimal, you have to multiply by the powers. Multiply by the powers. But if you are converting decimal to a binary, you have to divide by the new base. Divide by the new base. Okay, so this is the process of conversion of decimal number to binary number, or binary number to decimal. Okay, so I will give the assignment on this topic tomorrow. Okay, these assignment are based on the lab manual, so you have to save all the assignments or store all the assignments on single pages. Okay, don't lose that assignments. Okay, so all these assignments are a part of your lab manual. Statistics also, computer also, form 231 also. Okay, so this assignment I give, it is a part of a lab manual. So once you complete the assignment, the lab manual is also your completed. Okay, you don't have to write extra work, just you have to complete that assignment within the scheduled time. Okay, so take the attendance. घेतली attendance cap.
हो सर, झाली सर.
हा, घेतली का?
हो सर.
हा, ठीक आहे. ओके, उद्या पण 2 लेक्चर आहेत, टाइमावर या. ठीक आहे.
हो सर. थँक्यू सर.